Hey everybody, welcome back to the shop here at Tusa Acres. You look behind me, we got this monster welding turntable. It's a custom made unit. Picked it up recently and I got it for a song. I think I paid like 300 bucks for this thing. It is a monster, probably in the ballpark of 400 to 500 pounds. Way more than what I need. And a problem I run into, and that's why I'm making this video, is it's 3-phase. I live out here in the sticks, you know, we only got single phase at the house and in the shop. So what do you do, right? Well, VFDs, okay? They are your friend. This will be the second 3-phase piece of machinery I'll have wired up in here. This one was a little bit more difficult than the last one, so I'm gonna walk you through it. I am not a licensed electrician. I am not a professional. So take this with a grain of salt. This is just what I'm doing for entertainment purposes, right? That's what we're supposed to say. So I'll walk you through what I got set up and what I'm getting ready to do, and we'll take you for a quick trip here. So first up are the VFDs themselves, or VFD. So this one I have set up for a hydraulic pipe bender, and this one is going to be for this project. These are Schneider's, and yeah, I got these at an auction as well. So you got to make sure that the VFD is capable of running the equipment that you're trying to wire up. So this one is the M2 model. So we take a look at our annex here, and for this piece of equipment, M2 right there, for 3 horsepower, right at the upper limit of what I'm able to run with this VFD. So we're good there. Got to get it wired in. I used a 30 amp dual pole breaker, which is probably more than I needed, but got these two right here, a 20 and a 30, and I can swap those out if necessary. Now, honestly, understanding the language in these damn things is probably the hardest part of the entire install, is the programming. So we'll get to that here shortly. Got to get yourself an outlet or some sort of disconnect, or at least a way to transmit the power. So that's what we have here. And I'm going to be replacing this entire cord with that 12-4 right there. Now this is the part that honestly had tripped me up a little bit. I have not dealt with one like this before. They have an actual start-stop switching mechanism in here, Allen Bradley. And then they also have a transformer in here. Now this actually takes the 220/440 and steps it down to 110. You can see that. And what they do, or with this particular unit, this is electric over hydraulic. It's got a foot pedal down here for start and stop. So the operation of this bugger, it's pretty busy, to tell you the truth. So we got our 3-phase motor driving an electric pump that's down there in that tank. Then we've got this shuttle valve here, solenoid operated hydraulic shuttle valve. And then you can see we got hydraulic hoses going to and from a hydraulic motor that spins the entire chuck. So basically when you hit the pedal, it takes power from there, routes it through that transformer, sends that power up to this shuttle, opens the valves that allows hydraulic fluid to go to and from the hydraulic motor, all in one shot. Yeah, pretty busy. You'll have to take a look at the nameplate on your motor and get all the information off of that, because you're going to need that for the actual VFD. So what I'm going to do is basically delete this entire assembly along with the start-stop button on the control panel cover, or control box cover. All right, so here we've got, let's start here. We'll start with the power in from the wall. Right now, this is our power in from the wall. Comes in right here. We've got our 3 hots and our ground. Those 3 come up here. They go into the top of this Allen Bradley start-stop. Then they come back out down here, and that's what goes to the motor up there. Then they also have tapped right into 2 of the 3 lines going to the motor. That's 2 hots going to the transformer, and then coming out of the transformer, got a line going up there, comes out, goes to our shuttle valve, or our solenoid valve, comes back through, goes through our foot pedal, comes back out of there, comes back into here. So I can delete basically this whole thing and all of this switch mechanism down here and control the start-stop function of the motor itself with the VFD. And I'll program it so that it has a slow start, slow stop, you know, like a 2 to 3 second spin up time. And that's what I'm gonna do. And I could probably just go ahead and get this whole thing off of here, but rather than disconnecting everything, I'm just gonna go ahead and leave it on here. And when it's time, you know, if I ever go to sell this thing, at least all of it's still here. All right, now I will set up my new power cord. Now these, generally speaking, don't matter. I have found that the 3-phase motor doesn't really care which terminal it gets. However, the first time I fire this up, it's spinning the wrong way. All you have to do is swap any 2 of these and you'll reverse the direction of the motor. A lot of VFDs have the ability to just hit reverse, but the one that I'm using, I struggled with that when I was setting up the other one. So I'm not even gonna bother. I just found it's easier to go ahead and do this. I made that way too long, didn't I? Son of a gun. So we got our power cord hooked in here. Put our panel back in place. If you don't have yourself one of these types of screwdrivers, screw holding screwdrivers, don't need them very often, but I'll tell you what, every now and again, just like that. All right, now I'm gonna get these power wires wire nutted together. So we got our 3 mains and a ground. That should take care of our control box side. Now this next step is crucial. All right, so I've already disconnected all my leads to the windings, because if you look here, hopefully the camera can get this, shows you low voltage and high voltage wiring diagrams. So this was set up for high voltage. Now we're going to swap it over to the low voltage winding configuration. Let's just get T4, T5, and T6 all put together first. Get those out of the way. And we need 1 and 7. And these just get wire nutted right to our main hots. Again, no particular order on the hots. It's just if your motor spins the wrong direction, swap one of these around. You could do it here, you could do it at the control box, you could do it at the plug end. Doesn't really matter. Now we are on to programming. All right, so I did go back and button everything up. I didn't want those holes open like I said earlier. But I'm just gonna follow the quick start guide to a T basically. Now on this Schneider, when you first fire it up, it blinks ready, and if you press and hold the mode button, it takes it out of remote and puts it into local, because we're gonna locally turn on, turn off, you know, increase, decrease speeds, all that crap locally at the control panel here. You got to knock out this little button plug here, and I've already done that, so I don't need to do that again. So now motor, and we'll just go right on through it. OCF. I don't even know what OCF means. All right, let's try it again. Did not like that. Okay, gotta do a little research. Alrighty, peoples. Well, I had some time to think about this. Did a little research overnight, and I got some ideas. I already tore it all apart. I used this old school megger here, and I checked all the windings to ground, and everything checked out good for ground faults. So now I'm going to check phase to phase, winding to winding, if I can. I'm trying to figure this one out, and I took some screenshots of the setup. This is a Y or star style winding setup, like that. So I'm going to use that to figure out how to check phase to phase. 2 and 5, 1 and 4, 3 and 6. So this one should be 3 and 6. Yep. So now I'm going to check from phase to phase, phase to phase, phase to phase, and then each of these to this one, or this one to each of those. Got to be careful with these things. They put out some pretty high voltage. And you know what, just out of curiosity, I saw this method earlier to see if these things are accurate. So with the leads not touching each other, we'll just give her a crank and it should go maximum. There it goes. So needle went all the way up. That tells me that there's no continuity whatsoever. Now I'm going to put them together, and when I do this, it should go straight to 0. Oh yeah, and it's much more difficult to turn. It's weird. Okay, so we know that's good. So now we'll go back to our windings. I should get high resistance. I am. And it was around the 250. Now I don't know how accurate this is. 200, 300, 400, somewhere in that ballpark. 300 to 400. Now I'll switch this to the next one. Same thing. Okay, so I'm going to call that good as far as the windings go. And then now I'm going to check all of my wiring. And just as a side note, yesterday after I had shut off the camera, I don't know if you see this, there's a Lovejoy coupler up here. I rigged up a setup for my hand drill, and I was able to rotate this thing with just the hand drill. So if just this little bitty drill can spin that hydraulic pump. Now there's a lot of resistance there. I actually let a little smoke out of this poor DeWalt. But if that drill can do it, a 3 horsepower motor should be able to spin that thing up. Now I know there's a lot of resistance on startup that's causing too much current, and that's why the VFD is getting all pissy. So something is, I don't know, something's just not quite right, and that's why we're going through this troubleshooting little by little. Now I'm going to check all of the rest of my wiring, which I actually started doing yesterday. I took off the original casing, hard casing, because there was a huge ding in this thing, and I thought maybe that was causing an issue, but the wires themselves turned out to be just fine. No pinches, no open wires, no faults. So now I'm going to check all of my wiring from the actual VFD all the way back to the unit, and I'm going to, even though I don't think it matters, I'm going to make sure that I got the proper wires coming from the VFD to the outlet, from the outlet to the machine. Make sure that they're all in sync with each other, if that makes sense. So U1, V1, W1, line 1, line 2, line 3. I want them to be all the same, even though, like I said, I don't think it matters. That's what I'm going to check next. But I'm going to go black, red, then white. So T1, T2, T3 is the same as U, V, and W. So we'll go black to U. And I'm using 12 gauge stranded, which should be more than enough for, you know, the 10 amps or so of current. Anywhere from, 8 to 10. I think 12 gauge is usually rated for, upwards of 20 amps. So this should be plenty thick enough wire. And a Y. All right, so we'll go XYZ for black, red, white on both. Okay, now just for a sanity check, I'll check continuity from one end of my power cord to the other. Okay, I already have the colors kind of set up as close as possible. I got brown, orange, and yellow, so that's black, red, and white. Red. Everything checks out there. Something else that I learned, I definitely did not put the right power factor or cosine in there. So that's something I'll be changing here shortly. I should have known better because pretty much no motor, especially one this old, is 100% efficient or whatever they call it. And it's not written on the nameplate. The cosine power factor is not written on the nameplate, but I was able to find a data sheet. Now it's for a newer model of the same model number. So I'm going to assume that the older model is even worse than a newer one. And on top of that, according to date code, the motor we're working with is a 1974 model. But it all tests out good, so it should work. Okay, we're gonna get back behind this motor now and get these 3 leads hooked back up. So now red, black, and white should go T1, T2, T3. I'm not gonna bother hooking up the other stuff right now, the transformer and all that. I'm leaving that completely disconnected just to see if I can't get this motor to spin. Okay, so we're just gonna go through this entire programming process again. For frequency is 60, nominal voltage 220, 60, NCR 8.7, speed 1730, cosine, this is the one that needs to be at like 0.8. Then we have to do a tune. Here we go. Okay, so it's done with that. Now let's go to settings, ACC. Let's go ahead and put that back to, let's say 2 seconds. Now let's go back to 3. Deceleration, same. LSP, motor frequency at minimum reference, 0. High reference is 60. Nominal current on motor nameplate, 8.7. Then we need to go to that IO one. TCC is already on loc. Okay. That should do it. All right, so you guys should be able to see everything. We got the motor, should be able to see if it spins. So going in reverse direction, it spins freely. Going forward, spins freely until that motor, hydraulic motor catches, which is right there. So I'm gonna reverse it a little bit to clear that hydraulic pump. Maybe it can get up to speed. Let's see. Holy shnikes. Haha! Holy crap! I don't know what exactly I did to fix it, but she appears to be working. Oh shit, I can't believe this is working. Actually, I didn't notice if that was spinning the right direction. Nope, it's not. That's why. So that's why it's spinning freely now, because it's spinning in reverse. Shit. Screwed that one up. All right, so let's swap one of our hots. I'm gonna go ahead and kill power. I suppose I could have just unplugged it. Doggone it. Dang it. Dang it, dang it, dang it. That really stinks. I was so excited there. No power, so all I gotta do is swap one of my T1, T2, T3s and it should go the other direction. Well, at least we know the motor works, huh? That's funny, I just randomly wired this like 5 times yesterday. And it was, every time it went the right direction. One time I wired it the way I thought it needed to be wired. It goes backwards. Alrighty. Should all still be the right direction, or right hookups for everything. I'm not even sure what the hell I'm talking about. Oh, sorry, the right settings. I should still have all the right settings in here. Let's see. Okay, well, it was thinking about it. It's better than it went yesterday. Well, at least it's not doing an overcurrent right now. Holy crap! Oh, didn't like that. Overcurrent. Okay, well, we're getting there. Hey, at least it actually fired. That was the most it's done yet. I wish I knew how to clear this overcurrent. But what I am gonna do is go ahead and kill it and see if we can't get these other 2 wired in now. And maybe since I got it running long enough, we could actually test out that foot pedal. Okay, I wasn't getting anything on that foot pedal. Alrighty, more troubleshooting. Okay, it's been like 4 hours since the last part of the video, and I really had to take myself to school, but I think I got it. So I'm gonna take you through bit by bit and show you, and you know, just for future reference, you know, when you're setting up stuff like this, be prepared to learn basically everything there is to know about your machine. If you're gonna set it up all by yourself, you know, obviously you need to know a little bit of electrical, something like this, hydraulics, you know, mechanical stuff. So just be prepared to really dive off the deep end. All right, so the first part that I realized was screwed up is that this transformer here, it's a 240 or 220 440, and it's supposed to output 110. I checked my outputs and I was only getting 60 volts. So had to take myself to school on that, and it was still wired for the 440 volt previous setup. So I had to make another jumper wire and redo the basically 120 times 2, right? So that's the 240 setup there. Now I'm getting like 90 to 100 volts down here, which leads me to the next part of this. So this valve here controls flow to the motor, the hydraulic motor, which is right down there, okay? And that's when you hit the foot pedal, it actuates this solenoid and throws the valve and allows fluid to go to that motor. Well, first, obviously I wasn't getting 110, 120 volts, so I got that fixed, then I still wasn't getting anything here. So I took this whole thing off, threw it on the bench. And on the bench here, now this is a separate one. Fortunately, I had a second one, but I found out that one of the coils on the other one was bad, and that was this one here. See how brown that is in there? So this one had one good coil on it, and then this coil, which was bad. So out of the two valves together, I was able to make one good valve. Op checked it right here on the bench and got that taken care of. So then I was able to fire it up again, it was running, and if I hit the pedal and relieve the back pressure on the system, the motor would spin no problem. I could just sit there and stand on that pedal, the turntable would move, and I had no issues whatsoever. But as soon as I let off that pedal, I could hear the motor really go, really struggle. And I realized something was still backing it up. So I wanted to check the pressure. The gauge was screwed up. I tried fixing the gauge. It's still bad. Then I saw this little guy here, and that's just a little pressure relief valve. All right, you can set basically the system pressure here. So I backed this out, and lo and behold, she actually runs now. So I'm gonna back it off a little bit for startup, and then we'll go ahead and you'll see me go through and op check it. All right, so we're still plugged in, everything's ready to go. Just gonna go ahead and hit the run button. Fires right up. Now if I hit the pedal with that thing backed out all the way, I don't really get much here. I mean, I can open the flow control valve down here and I'm still not getting much. So then I start turning in the relief valve over here until I hear the motor start to catch the hydraulic pump. Hear that difference? So now I know the hydraulic pump is starting to catch. And there we go. Now I can slow it down using the flow control valve. And it's kind of weak. I'm sure this is very low pressure, so crank it a little bit more. I mean, we're talking about welding here, so it needs to be able to turn really, really slow. There we go. Yeah. Even slower. But it can also go really fast. Obviously, it'll never be welding at that speed. But man, this is awesome. I don't want to run it too long because I still don't have the fan put on there. So just for motor cooling purposes, which, I mean, that's nothing for this motor. It's still cool to the touch. So yeah, there we go. So I'll go ahead and get the rest of this put back together, you know, get all the wires and sheaths and get it all put back together, cleaned up later. It's, I don't know, 6:30 at night right now, and yeah, I'm donezo for the day. This has been a couple days in the works now, and I'm glad I finally got it done. Hey, thanks for stopping by. If you like this kind of stuff, please hit the like and subscribe buttons. If you got any suggestions or questions about any of this or anything at all, really, feel free to throw it down there in the comments. And if anybody has any practical experience with those valves, there's actually a second wire on there that's supposedly getting hot. Well, it is getting hot, you know, 110 from that transformer. And I don't know why. The shuttle only seems to go one way. I even hot wired it the other way and it still worked the same way. So maybe it's neutral position, sends fluid back to the tank, and then it either left or right, that shuttle valve will send the fluid to the motor. You know, I didn't pay attention. Maybe that would reverse the flow and reverse the turntable. I don't know. So anyway, yeah, if anybody knows anything about that, please throw something down there in the comments. All right, hey, thanks for watching. We'll catch y'all in the next video.